Okay, question 2 from the polymers and giant covalent substances. We're looking at a large molecule. So this is in the previous question. This is a polymer molecule, and it's asking us for the molecular formula of the polymer. Now, the molecular formula of a substance is the actual number of atoms within the actual molecule. So it's not an empirical formula, which is the simplest ratio. This is the actual number. And so what we can see is we've got a C2H4 unit within the bracket, but that is a repeating unit and is going to be repeated by n number of terms. So the molecular formula for this is going to have to be worked out algebraically, and so it's a C2H4, but it's repeated by the unit of n. And so n could be many thousands, which, when we go into the second question, is asking you is if this molecule were to exist, obviously this would be a polythene molecule, is it likely to be a solid, liquid, or gas? Now, the first issue is it's likely to be a solid. And the reason, because is n could be, as I say, could be in the thousands. So what that's going to do is that's going to make this a very large molecule. And so, because we're going to be looking at the bonds between different large molecules, that means that the intermolecular forces of attraction that are going to exist between those large molecules are going to be equally large. And so, as a result, lots of energy is going to be required to break that large force. And as a result, it's going to be a solid, which is going to need lots of energy to melt it when it gets bigger. It's required to break the bonds and melt the solid to give the answer. Okay, so it's the weak intermolecular forces of attraction that we're breaking here. But the issue is, because we've got such a large molecule, that relatively weak force ordinarily is made large because of the size of the molecule. However, the bond that holds the atoms together, that is a covalent molecule, that is a covalent bond. That is the bonds we're looking at here, is these bonds here within the actual molecule, the actual sticks in the displayed formula, and they are covalent bonds, shared pairs of electrons, as we have looked at many times.